So welcome everybody to our next video on partial fraction decompositions. All right, so from the last video, we know kind of how our expressions are going to break down. That we've got something like 5x minus 7 over x minus 1 times x minus 2. We know we've got two factors, two linear factors, so I'll have one factor for x minus 1, and I'll have one factor for x minus 2. Since those are linear, then my numerators are both just going to be constants, so I've got a and b. So now the question is, how do I figure out what a and b are? Well, there are a few different ways of doing it. Kind of the one way that's guaranteed to work in every single case is to set up a system of equations. Now, how we go about doing that is to first clear denominators. So our first step is clear denominators. So we have essentially multiplying both sides by x minus 1 times x minus 2. So 5x minus 7 times our x minus 1, x minus 2. Our x minus 1 times x minus 2 times a over x minus 1. And then our x minus 1, x minus 2 times our b over x minus 2. So what happens when we clear those denominators? Now, on the left, both of our factors, so our x minus 1s will cancel, our x minus 2s will cancel, and we are left with our 5x minus 7. Then our x minus 1s cancel, so we have a times x minus 2. And our x minus 2s cancel in our second term, so we have b times x minus 1. Okay, so now we can distribute our constants and combine like powers of x. So if I do that, what happens? I end up with an ax minus 2a plus a bx minus b. Now combining my powers of x, I will have an a plus b, so an a plus b times x, and then I will have a minus 2a minus b as my constants. Okay. Now I compare this to my polynomial on the left-hand side. So basically the idea is I get a system by equating coefficients of powers of x. Okay, so I get a system by equating coefficients of powers of x. And so I look at 5 and a plus b. So I have one equation that says 5 is going to be a plus b. And then I have another equation where I equate the constants. So I've got a constant of negative 7. And what is my constant on the right-hand side? Minus 2a minus b. And so now I have kind of reduced this problem of figuring out what a and b are to a system of equations. And so now it just depends on how you wish to solve that system of equations. So in general, if we have kind of really big systems that we might need to solve, then in that case, we might want to think of a pretty big gun to solve these things, and that's called Cramer's rule, which really tells us how we can go about finding the solution to this equation using determinants. So find my solutions to the system using determinants. Now, in this kind of case, it's a 2 by 2 system, so that's really not very big. It's not really hard necessarily to do that, but in the situation when you have bigger systems, this might be the kind of gun that you really want to go to help solve those. But for something small like this, we could really just do something even simpler and say, hey, what I'm going to do is add those two equations together. If I do, then what happens? 5 minus 7 gives me a negative 2 over on the left. A minus 2a gives me a minus a over on the left. And the plus b cancels out with the minus b. So really what I have is that a is just going to be 2. And so what that means, kind of easier than that, a is going to be 2. So what do I have? 5 is equal to 2 plus b. And so b is going to be 3 at that point. And so when the system is small, it might be easier to just add or subtract the equations together to go doing it. When your system gets big, if you have 4, 5, 6, 7, 8 or more coefficients that you need to determine, then you may want something a little bigger, like Cramer's rule, to help you solve the system in that way. But generally, the idea is the method that always works to find our coefficients is to take it and form, so we clear denominators, form a polynomial. So kind of if we write down the steps, I guess, to summarize maybe what we've done. Okay. So we first clear denominators. We clear denominators to get rid of everything in, so we're essentially only dealing with polynomials at that point. Then we expand and group terms by powers of the variable. And so we put those together. And then finally, our last step in that was that we form a system by equating powers of x. Okay. So that was kind of our steps in doing this. Once we had that, this gave us a system, and then kind of we reduced that problem even further to solving the system. And so this has kind of been a method that will get you through everything. So writing the linear equations. Let's try one more example in where we have an irreducible quadratic and see what that system might look like. All right, so in this example, now we've got a quadratic, 7x squared plus 2x minus 11, over a cubic, x minus 2 times x squared plus x minus 1. So we've got an irreducible quadratic, and we've got a linear term. So I know that in my partial fraction decomposition, I'm going to have a constant over the linear term, x minus 2. And then I'm going to have a linear factor, so bx plus c, over my quadratic, x squared plus x plus 1. Okay. So kind of the same thing as we did before. Our first step, we clear denominators. Okay, so if we clear denominators, what happens? So now we've got an x minus 2, x squared plus x plus 1 times our x minus 2, x squared plus x plus 1 in the denominator, 7x squared plus 2x minus 11 in the numerator. And then we have our x minus 2 times x squared plus x plus 1 times a over x minus 2 plus and x minus 2, x squared plus x plus 1 times a bx plus c over x squared plus x plus 1. So when we clear denominators, on the left side, both factors will cancel out. So we'll be left with 7x squared plus 2x minus 11 over on the left. Then on the right, in the first term, our x minus 2's cancel out. So we have a times x squared plus x plus 1. And our x squared plus x plus 1's cancel out in the second term. So we have a bx plus c times x minus 2. And so now we've cleared denominators. Our next step is to multiply everything out. So now for our second step, we will expand our polynomial. So now we need to expand and group powers of x. So if we do that, let's see what happens. So over here on the left-hand side, nothing much happens. We've got our 7x squared plus 2x minus 11. But then over on the right-hand side, we've got ax squared plus a times x plus a. And then if we expand on the other side, we've got our bx squared minus 2bx plus cx minus 2c. Now, if we group our powers of x, then what happens for our x squareds, we've got an a, and then we've got a b for our x squareds. We've got, for our x's, we've got an a, we've got a minus 2b, and then we've got a c times our x's. And then finally, for our constant, we've got a minus 2c. And so what we do now is we start equating coefficients. So equating coefficients, so our third step is to form a system by equating coefficients. Okay, so what we're going to do then is to say, all right, for the coefficient for x squared, that's going to be a plus b on the right, and so it's 7 on the left. So I get one equation that looks like 7 is equal to a plus b. Then, for my coefficient of x, I've got 2 on the left, and I've got a minus 2b plus c over on the right. So that gives me a 2 is equal to a minus 2b plus c over on the right. And then finally, for my constants, I've got negative 11 over on the left. Oops, let's go back to the right color with that one. So I've got negative 11 over on the left, and over on the right, I have a minus 2c. So I form this system by equating those coefficients. So I've got 3 variables and 3 equations. That's going to give me a solution. So now we have our system that we need to solve. So we've got 7 is equal to a plus b, 2 is equal to a minus 2b plus c, and 11 is equal to a minus 2c. Well, something that we can do to kind of simplify these things, we can really get rid of our variable a by saying that from our first equation, a is going to be 7 minus b. So now if I take and I substitute into the other equations, I have 2 is equal to 7 minus b minus 2b plus c. So if I simplify this, I have 7 minus b minus 2b is minus 3b plus c. So I move the 7 over to the other side. So 2 minus 7 gives me a negative 5. and I have a minus 3b plus c. For the second equation, I have negative 11 is equal to, let's move that a little further down. So I've got negative 11 is equal to 7 minus b minus 2c. So this gives me minus 11 is equal to 7 minus b minus 2c. Well, moving the 7 over, I'm going to have a minus 18 is equal to negative b minus 2c. And so this reduces to a 2 by 2 system for which I have negative 18 is equal to negative b minus 2c, and negative 5 is equal to negative 3b plus c. So now with a 2 by 2 system, what can I do with that? Well, if I scale the second equation by a factor of 2, we can actually add things together and cancel terms. Okay, so by scaling our second equation, what we can have, so we don't do anything to the first one, so minus 18 is minus b minus 2c. Multiplying the second equation by 2, I get a minus 10 is equal to minus 6b, and then plus 2c. So that whenever I add those two equations together, what do I have? Our minus 2c's cancel. I get a minus 7b, and I get a negative 28. Which then turns around and tells me that my b is going to be 4. So I found one of my values. One of my values is b is going to be 4. Now, from my previous, what I did with my substitution, remember that we had that a was actually going to be 7 minus b. So now that I know b, I also know a, so 7 minus 4. A is going to be 3 in that case. So now I've gotten A and I've gotten B. To find C, I just come back to one of my equations where negative 11 is equal to A minus 2C. So now I know what A is. A is going to be 3, so I get negative 11 is going to be 3 minus 2C. So that, when I subtract 3, I get a minus 14 is equal to negative 2c, and so c is going to be 7 at that point. And so now I know what my partial fraction decomposition is. I can rewrite that. So I knew that my 7x squared plus 2x minus 11 was going to be a over x minus 2, and then bx plus c over x squared plus x plus 1. And so knowing what a and b and c are going to be in this case, I actually have that. A is going to be 3, b is going to be 4, and c is going to be 7. And so at that point, now I have my coefficients. I've got my coefficients, I've got my partial fraction decomposition, and I've got my rational expression broken up into the sum of more simple terms. So this is kind of a couple of examples of how you take these things, form a system from them, and then solve the system. So let's maybe do one more video where we can see a couple of shortcuts that might simplify our process a little bit.